My name is Keith Carlock, and I'd like to introduce you to my theory of hyperintersections, solutions to point-like infinities. And I'll try to include a video, another YouTube video that sort of supports my own theory. It's their own geometric take on points. But this is a point, a representation of a point that I tried to draw with an infinity of lines, and it can't be concentrated. It's a point. It can't be concentrated any further. That's two constraints it has on it. And it's also built on an assumption of a dimensionless point of a place in space, a position in space. These are some graph diagrams I drew pretty much freehand, and this shows an off-center, center, off-center, and center intersections. I call them fractal intersections or hyper-intersections, and these are hyper points, hyper or fractal lines. This is one fractal line. These are pairs of fractal lines. These are pairs and three fractal lines. And these ideas go along with my idea of an invisible holographic principle, a concentrated intersection of reality. That's one thing that a point doesn't have, a concentrated intersection. It can't be concentratable. And it goes along with my invisible holographic bound, which is based on my idea of hyperintersections. And this is pictures of the hyperintersections of better pictures. And you see that the first triangle is off center, ones centered 1 2 1 2, off center 2 2 2, centered 2 2 2 3 2 3, off centered 3 3 3 3 3, and centered 3 4 3 4, and off centered 4 4 4 4. And you can count the numbers, and they go from 6 to 8 to 10 to 12 to 14 to 16 to 18. And these are my ideas of a hyper topology that is a solution to point-like intersections, point-like infinities. And it doesn't have the constraint of infinities because there's only a finite amount of times you can go through a graph with the nodes. And it's concentratable, as shown in this figure. It's concentratable, whereas a point can't be concentrated any further. So there's the solutions to the infinities. And this is based on another idea of mine, but all this goes towards my idea of an invisible holographic principle. Our universe out here, a hyperbolic universe inside the concentrated intersection, and that supports my invisible holographic bound of an invisible holographic principle. All of these ideas I'm trying to come together to create an invisible holographic principle. An amended invisible holographic principle. And these ideas all go to support my ideas of portal technologies, future portal technologies. And the constraint for that is the ghost interfacing paradox. And I discussed this at some length in another video, but if you want to freeze this picture, you can read what the ghost interfacing paradox is all about. And again, it's concentrated, finite, hyper intersections, and these are all my ideas of an invisible holographic bound, and the idea that where space itself disappears, it must reappear somewhere else, and that's based on Landauer's principle of information. If information is a part of space, or space is the whole of information. So, but the main gist of this video is the hyperintersection topology the solution to point like infinities, and they follow a pattern: ones, 1 2 1 2, 2 2 2s, 2 3 2 3, 3 3 3s, 3 4 3 4, 4 4 4s, 6 8 10 12 14 16 and 18 if you count each end of the intersection. And this shows an intersection again with a concentrated intersection, which could be used to make portals, concentrated intersections. And so all this goes together. So I think I'm repeating myself now, but thanks for watching, and I'll try to include that YouTube video. It's called CPS Geometry. It's somebody's own take on their solution to. They rely on spheres. Spheres points to them are tiny spheres. What I'm saying points to me are fractal spheres. Spheres with intersections, finite intersections. This is a cross section of a sphere, so they're more like fractal spheres that can allow intersections, finite intersections, and they're concentratable, which ultimately leads to portal technologies. And this is the constraint of portal technologies, in my opinion, in my educated opinion, I guess. And so, well, thanks a lot for watching. And here's another one. You can freeze this if you want to. Yeah, thanks a lot. Bye.